So, transposing formulae. By transposing formulae, I mean rearrange the formula. So it's another word for rearrange the formula. Here's a formula for this volume of a cylinder. You might recognize it. And I want to transpose the formula and rearrange it so that I make L the subject. In other words, at the moment, this formula has got V as a subject. It's set up to find the volume. Volume equals, and then here's what I do to get the volume, the recipe I follow to get the volume. I want another recipe that tells me how to find the length. If I know what the radius is and the volume is, how do I find the length? So I transpose the formula and make L the subject. Let's have a look at this formula, this right-hand side for a minute. It means the number pi, which we know, 3.14 something or other, multiplied by, so no symbol means multiply, radius, whatever the radius is, it's a number, squared. So the radius is squared, times again by the length L. I can clump together parts of it. I can think of pi r squared as a number. I can think of r squared times L as a number. So I can sort of, if not literally, in my mind, put brackets in and group numbers together, components of this right-hand side recipe together. So looking at this, what I think to myself is, this whole number, pi r squared, has been multiplied by the length to get the volume. So if I want the length, I need to get rid of this pi r squared, and then I have the length. How do I get rid of it? I divide by that whole number, pi r squared, and I've got it. So I divide both sides by pi r squared. Pi r squared. Divide both sides by pi r squared. Which means that this cancels. I could do it in steps. I could divide both sides by pi to get rid of the pi, and then divide both sides by r squared to get rid of the r squared, and that would be perfectly valid. But remember, you can lump things together like that, so do it the whole lot in one go is fine. So divide both sides by pi r squared, and I'll have that v over pi r squared equals the length. I've transposed it, I've done it. It's traditional to write the subject of the formula on the left, so the final step would be to write length equals v over pi r squared. And now I've got a new formula to find the length. If I know v and I know r squared, r rather, I can find the length. So let's transpose this formula for r. Another way to think about it, if you're trying to transpose a formula, is to think about, I talk about the story of the right-hand side. How was this built up? If I were to start off with r, what do I do to end up at pi r squared over L? And what are the steps I follow? The first thing I would do, if I was building up the story of this right-hand side, I'd start off with r. And what's the first thing I would do in my quest to get pi r squared L? Square it. And then what would I do? Times by pi or length, it actually doesn't matter, does it? I've got to times by pi and L, so I could do it all in one hit, couldn't I? Times by pi L, and I'll end up with, so that's times by pi L gives me this, and I've got that side, r squared pi L. That's the story. So this is what I've ended up with, pi r squared L, which is the right-hand side, but I want that. So effectively, I want to go backwards down this chain. So what I do is I undo it in the same way as it was built up. If you're not sure what the first step is, think about what's the last thing that was done, in other words. That's another way of saying what I've just said here. What's the last thing that happened to this pi r squared L? The last thing that happened was it was times by pi and L. Because the first thing I have to do when I'm building this up is square. That's the key thing, isn't it? So I don't square root. I want to square root to get rid of the r squared, but I don't do that first. If I square root both sides, I end up with the square root of v equals the square root of pi r squared L, and I'm nowhere near, not near finding r is, or getting r as a subject rather. So the first thing I do is divide both sides by pi L, and I get v over pi L equals r squared. And then I square root. Square root both sides. The square root of v over pi L equals r. And then write the r on the left-hand side. Again, I could have divided by pi and L, one at a time, but group them together and divide by both at the same time. So this one, and we're on the way now to more complex formulae, you have to think about what are the steps. And it's important to do the steps in the right order. If you do them in the wrong order, it's not wrong in the same way as equations. It's not wrong so long as you do the same thing to both sides, but it can be not helpful. It won't get you any nearer what you want if you do the wrong step first. So here's another one that you might recognize as one of the equations of motion, v equals u plus at. And we could rearrange that for u. What would we do? Subtract at from both sides, yeah. This at, it doesn't matter what at are. I don't know what a is and I don't know what t is, but they are numbers. So a times t is a number, which has been added to u, which is what I'm after. So subtract that whole number from both sides. V minus at equals u. And then again switch it so that u is on the left-hand side by convention. There is, again, a whole chapter on transposing formulae, and they start off with fairly straightforward formulae and build. If you're feeling confident about transposing formulae, go to some of the more complicated ones that are in the further exercises in the text. So just make a note, and again during the tutorial session you can have a go at a few. I'm not sure, but you'll find it, the chapter on transposing formulae. Again, solutions up here on the website, maths@lowestoft.college. So you look at these exercises and you get stuck on one, you'll find I've done a video of the solution. And what I nearly always do if I do the solution is give you another one to try, like it, so that you can practice it. Let's have a look at one more. A bit more of a complex one, this one. Just pause while you write it down. So in this one I want to make A the subject. A appears twice. I don't know what A is, but I do know that whatever it is, it's the same. So A squared is the same, it's a number. So A squared is common to both of these terms. So I can take that outside the bracket, factorize in other words, which is one of the little basic algebra things we were looking at, this idea of expansion and factorizing. So that's in my mind that if the thing that I'm after appears twice, I'm going to try and factorize and take that outside a bracket, so then it only appears once. So that's in my mind. Also what's in my mind is I don't like that r underneath. And if you look at the right hand side, this whole term at the top, a squared x plus a squared y, has finally, hasn't it, been divided by r. The last thing was that all that term on top was divided by r. So the first thing I'm going to do is get rid of that r by multiplying by r. So I'd multiply both sides by r, and I'd get PR equals a squared x plus a squared y. And then I'd factorize. I'd take the a squared outside a bracket and ask myself, what have I got to times that a squared by to get back to a squared x? X. So x inside the bracket. What have I got to times a squared by to get back to a squared y? Y. Plus y. So plus y. So now I'm nearly there. Remember, a squared now has been times by this whole expression. So let's get rid of that by dividing by that whole expression. If I divide by this whole bracket, x plus y, I can cancel the whole thing, because whatever that is, x plus y is a number, it's the same underneath, so they can cancel out. So divide both sides by x plus y, PR over x plus y equals a squared. I can leave the bracket around the x plus y or leave it off. It's not essential now to put the bracket in. And then finally now, last step. It's often the last step when it's squared. It's almost invariably the last thing you do is square root once you've got the a squared on its own. And at the same time I move that to the left, so a equals the square root of PR over x plus y. But, you know, hopefully you can sort of see those steps, and if they didn't come to you instantly, well, that's only a matter of practice.